Hey everybody, it's me again. Last week you guys reviewed a method for factoring trinomials that you had seen back in Algebra 1. So I just sent you to a random video I found on the internet that seemed to do a pretty good job. This method we'll talk about today is a variation of that, and like most things, you might like it better, you might not like it as much, but since you probably didn't see this method last year, I wanted to make sure to give you some nice detailed instructions since it's not really a review. If you prefer the box method for factoring because it's more familiar, then, be my guest. That's how this always works. But this gives you another method. This method is a little bit closer to what I personally do. I didn't learn the box method until I became a teacher. So this is a little bit closer to what I do myself. It's less visual, but maybe a little bit quicker. But mathematically, it's all the same basic idea. You're just not organizing it into that box. So I have an example here for us to work through just one step at a time. And then the video for the homework, the video that Mr. Burton made, walks you through all of those examples as well to give you lots of good practice with this method. But again, if you prefer the box method, then stick with it all as well. So we're trying to factor this trinomial. Remember, trinomial just means that it has three terms, 6x squared, positive 7x, and a negative 5. And the grouping method goes by tons of different names. Grouping, I think, makes the most sense for reasons we'll look at in just a minute, but some people call it the split the middle method, which also makes sense, like we'll see in a minute. The first time I saw this method, it was called the British method. This is apparently how most people in England learn how to factor. But in England, they call it factorizing because they're very fancy. But we're going to start exactly the same way as we did with the box method, or really pretty much any method for factoring starts the same way. First, I'm going to look to see if my cat is going to get in the way. Yes. Then I'm going to look to see if there's a GCF, or a greatest common factor, for all three terms. And so what I'm going to do is I'm first going to look at the coefficients, just the numbers in front, and I'm going to see if I can divide those by anything other than 1, any whole number other than 1. For 6 and 7 and negative 5, the biggest whole number that goes into all of those would be 1, so there's no reason to try to divide everything by 1. Doesn't really serve a purpose. Then I'm going to look at the variables. I see an x squared on the first term. I see an x on the second term, but then I see no x's at all on the last term, which means I can't take any x's either. So for this example, there is no GCF for all three terms, no greatest common factor other than a boring old 1, which isn't worth factoring out. So step 1, I really just get to skip over. Step 2, again, just like we did with the other method, with the box method, we're going to take our first coefficient, 6, and our last number, that constant including the sign, and we're going to multiply those together. So we're multiplying the first and the last. If you think back to Algebra 1, you would have called the 6 A, the positive 7 is a B, the negative 5 is a C. So officially what we just did is we multiplied A times C. Notice that we're ignoring the variables here. Some people keep the variables in it, and I think that just makes it too complicated. So I'm just doing 6 times negative 5, and that's negative 30. So then step 3 is where most of the thinking tends to happen, and often where a lot of the frustration tends to happen. Step 3, just like we did with the box method, we're looking for numbers. So we want to find two numbers that do two things. They need to multiply to the thing we just found, that A times C, and they need to add to give me that middle coefficient, B, which is positive 7. So we need two numbers. I will call them blank and blank, and I need blank times blank to give me negative 30 like we just found, and I need blank plus blank to give me positive 7. This just takes some trial and error. You need to be careful with your signs. Sometimes the numbers are going to stand out to you right away. Sometimes they're not. But that doesn't mean you have to give up if you don't come up with them right away. First, think about your signs. If two things multiply to give me a negative, then I need one of each sign. I need a positive number and I need a negative number. If they multiplied to give me a positive 30, then maybe it was a positive times a positive or a negative times a negative, but they multiplied to a negative number, so they need opposite signs. And then I'm just going to focus on the 30, not the negative at this point, and I'm just going to make a list, but not just a random list. I'm going to make an organized list where I start small. So I'm just going to write out a few numbers. And again, this is only if the numbers for those blanks, if they're just not standing out to you. So I'm just going to write 1, 2, 3, 4, 5 and see what I can do to make this 30. So 1 times 30, 2 times 15, 3 times 10. Really, you could say I'm dividing here, right? 30 divided by 3 gives me 10. That would be another way to think about what I'm doing. Because then I get to 4 and I'm like, 4 times... Maybe I don't know my multiplication tables, maybe I'm just not confident. And so I could say, all right, well, what's 30 divided by 4? Well, it's not a whole number, so this is off the list. 5 times 6 gives me 30. And then I just keep my list going and I realize, oh, I already have a 6 over there, so that means my list is complete. 1 times 30, 2 times 5, 3 times 10, 5 times 6. Those are my 4 possibilities. Then I bring back the signs, the positive and the negative. So I think even with signs, is there a way for me to use a 1 and a 30, one is positive, one is negative, to get them to add up to this positive 7? And the answer is no, I can't. So that option is out. 2 times 15. If I play around with positives and negatives, can I get a 2 and a 15? Maybe a negative 2 and a positive 15? Maybe a positive 2 and a negative 15? Well, neither of those gives me the sum that I want, so that's out. A 3 and a 10. If I play around with the signs, can I get those to make a positive 7? Yes, I can. I can use a positive 10 and a negative 3. They definitely multiplied a negative 30. That's how they ended up on the list in the first place. But also, a positive 10 and a negative 3 also add to give me the positive 7 that I wanted. So these are my two numbers, a positive 10 and a negative 3. With practice, that step of finding those two numbers, what I'm calling step 3, with practice it gets way, way faster than that. And even for some problems, it's already going to be way faster than that. I just went through the process of like, what if the numbers just don't stand out to me? Well, that's when you make your list. Once you have those numbers, now this is where it starts getting a little different, quite different in fact, from how we organize the box method. So let me recopy the problem. 6x squared plus 7x minus 5. With the box method, I'll just scribble that over here. You would put your 6x squared in the first spot, your negative 5 in the last spot, and then you would use the numbers that you found, that positive 10 and negative 3, to fill in these other boxes. You would just attach x's to them, a positive 10x, a negative 3x, and then you would go from there, right? Here we're going to do really the same thing, just not in a visual way, so it doesn't take the time to like draw the cute little box and everything. What I'm going to do is, for the problem, I'm going to take the 7x and I'm going to split it up using the numbers we just found. Essentially, I am uncombining like terms. So that's positive 7x. I'm going to write that as a positive 10x minus 3x. You'll notice in the box method, really that's what we did as well. We just put them in different boxes, and here we're just writing them separately. The 6x squared hasn't changed. The negative 5 hasn't changed. But this step, if I'm adding to my list of steps over here, what we just did is why some people call this a split the middle method. Instead of combining like terms like we're used to doing, we actually uncombined the 7x to get these guys. Because once we've done that, we've gone from a trinomial with 3 terms to just a bigger polynomial with 4 terms. 6x squared, positive 10x, negative 3x, and negative 5. So then the reason that other people call this the grouping method, and that's what we've decided to call it in geometry, is because we are going to literally group those 4 terms into 2 groups of 2. I'm going to take this first pair, 6x squared plus 10x, and I'm going to do some work with that. And then later, I'm going to take the second pair of terms, negative 3x minus 5, and I'm going to do some work with that. Like I said, really it's the same idea as the box method, because with the box method, you would have done some work on the top row, which is 6x squared plus 10x. You would have done some work with the bottom row, negative 3x minus 5. So mathematically, it's exactly the same, which is why it doesn't matter what method you use. It's just a matter of whether you like the pretty box or you like just kind of writing rows of work. So when I said I was going to do something, let's talk about what that something is. For the first pair, totally ignoring the other pair for now, I'm just going to look for the GCF between 6x squared and 10x. Between a 6 and a 10, I can divide both of those by 2. That's the best I can do. So that's my greatest common factor for the coefficients. For the variables, well, they both have at least one x, which means I'm allowed to take an x out. And so I'm factoring out a 2x from each of those. So this 6, well, I divided that by 2. So now it's a 3. There was an x squared, but I took away an x. So now there's an x. I'll do the same for the next yellow term. I had a positive 10 coefficient divided by 2 is a positive 5. And this term had an x, but we took it away. So there's no x left, and that pair is finished. Here again, we're kind of just working backwards. Instead of multiplying stuff, we're factoring. But you could actually really easily check your work right here. If I distributed this 2x back in to those parentheses, I would get back to where I started with the yellow pair. So it's really easy to check your work as you go through this process. So we've taken care of the yellow pair, and now as its own completely separate task, we're going to work on the blue pair. I'm going to do the same thing. I'm going to take out a greatest common factor from the blue pair. But there are a couple of tricks here, and that's why I chose this problem. If it starts negative, you need to factor out a negative. There are a few different reasons for that. We'll talk about one of those reasons in just a minute. But if it starts negative, like this one did, you have to take out a negative. Doesn't matter if they're both negative or not, just the first guy. Then I'm going to start thinking about the rest of the GCF. Between a 3 and a 5, well, there's no great number to divide both of those by other than 1. But I am going to write the 1 to remind myself of something that I'll need a little bit later. Then I'll look at the variables. This term had an x, but no, this term didn't have an x. So I can't take an x from both of them. So I won't take an x at all. And so then we'll see what's left. I had a -3 coefficient, but I divided out a -1. -3 divided by -1 is +3. This term had an x. I didn't take any x's, so it still has an x. For the other blue term, I had a -5. I divided by -1. -5 divided by -1 is a +5. And now I've factored out the GCF of the blue pair. Okay. So on my list of steps, let me write what we just did. We took out the GCF of the first pair of terms, and then we took out the GCF of the last pair of terms. I don't know if you want to count that as two separate steps or not, but I'm saying it's all step 5. So now, hi Kat. So now let's talk about why I took out that negative. I said, well, if it starts negative, you take out a negative, but why did we do that? This is why, and this is how we can easily check that we're good so far. The leftovers here, the stuff in those parentheses, for the yellow pair, it was 3x plus 5. By factoring out a -1, that made the parentheses for the blue pair exactly the same. And that's what we want. If that doesn't happen, then something has gone wrong. Maybe you split the middle using the wrong numbers. Maybe you took out a GCF incorrectly. Maybe you forgot to take out a negative if it started negative. But because those are the same, we know that we've got it so far, and we're basically ready to answer it. Now we're going to take the yellow pair and the blue pair. We're just going to put them together. The thing that they had in common that helped us know we were on the right track was this 3x plus 5. That showed up in both pairs, so I'm going to write it once. And then I just write the GCFs we took out. This 2x from the yellow pair and the -1 from the blue pair. And we're finished. So here in my list of steps, really, my last step is just to answer it. We ended up with 2 sets of parentheses. The first set was whatever they had matching. In our case, it was this 3x plus 5, 3x plus 5. So that matching piece. And then over here, officially, that's the GCFs that we found. But usually I just call this the outsides. The 2x was outside parentheses, and that -1 was outside parentheses. The order of your answer does not matter. Depending on how you started this problem, depending on how you chose to do the very last step as well, you might have gotten a 2x minus 1 first, 3x plus 5 second, completely fine as well, because if you think about it, this is a multiplication problem, right? And if I do any sort of multiplication problem, order doesn't matter. 3 times 7, 7 times 3, they mean the same thing. And factoring is just saying, here's a multiplication problem that gives us the answer that we saw at the beginning. If you feel comfortable with that, you can go ahead and stop the video. I do want to show you how you can check it super fast. But if you feel like you've got the hang of it, then you can go ahead and get started on the assignment. But checking is super easy. We just check by multiplying. If we think that this is our answer, or if we had in the opposite order, doesn't matter, we're going to multiply this out. You might multiply by the box method. That's something else you learned last year. 3x, whoops, that's not right. 3x plus 5 and a 2x minus 1. And again, it doesn't matter who you put across the top versus down the side. You could just turn your box if you wanted to. 3x times 2x, 6x squared. Positive 5 times 2x is a 10x. 3x times negative 1, negative 3x. Positive 5 times negative 1, negative 5. And then we just start combining terms. So I see a 6x squared. And then I see some like terms here. Positive 10x, negative 3x. It's no coincidence that positive 10 and negative 3 are the numbers we found early on in this problem. And then at the end, I see this minus 5. And sure enough, that was the question they asked me to factor, so I know I've got it. So you can check it using the box method. You can also just check it by doing the FOIL thing, which we've talked about why I don't like that very much, but just distributing, right? If I take the 3x and I distribute that, ba-dink, 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. And then I'll repeat. I'll distribute the positive 5. Bada bing, bada bing. And so positive 5 times 2x is positive 10x. Positive 5 times negative 1 is negative 5. You will notice, again, no coincidence, that the box method and this method have a 6x squared. The box method and this method both have these like terms using that 10 and negative 3 we did when we were factoring. And the box method and this method both give me a negative 5. So all I do is combine those middle terms, negative 3x, positive 10x, and bring down the unlike terms. 6x squared, positive 7x, negative 5. There again, mathematically identical to the box method over here. It's just, to me, it's a little bit less writing, which I kind of like, but for other students, the visual of the box is helpful, and it works exactly the same with factoring. Some people like to factor with the box, and some people think that's too much writing and drawing. It is completely up to you. There are roughly 8 billion different ways to factor. You can Google factoring trinomials to see, like, I just learned about a new one when I was looking for a video to share with you for this. It stinks though, you don't want it. But anyway, there are tons of good methods. The short answer is it doesn't matter what you use as long as it works for you. Factoring by grouping, as I said, is probably the closest to the method that I use, but I've been doing it for Lord knows how many years, 20 years at this point. So just pick what works for you. The assignment, it's called factoring by grouping. The instructions say to factor it by grouping, which is the method we just talked about. But again, I don't care. If you want to keep practicing the box method, then be my guest. But this is actually, this is weird. This is the last assignment for geometry for the whole year. So I'm trying to put something together for us to do maybe that last week of school to kind of get together in like a Zoom chat or something. So that's in the works. I'll talk to you guys. But in terms of math work, do the assignment and that's it. So congrats. Bye guys. I miss you like crazy. Bye.